name is HALIHMATUL, and today I'm going to present my part, which is the stearic acid. So stearic acid or octadenoic acid is a saturated fatty acid commonly found in animal fats and plant oils. Its name originates from the Greek word steer, which meaning tallow, reflecting its early identification in animal fat. This stearic acid is widely used in soaps, candles, cosmetics, and industrial applications. It is also valued for its stability and versatility structurally. It features a methyl group, CH3, and a carboxylic acid group, which is COOH, disconnected by the single carbon-carbon bonds, making it resistant to oxidation and rancidity. Stearic acid is abundant in tallow and lard, where it can make up to 30% of the fat content. It is also sourced from plant oils like hydrogenated palm oil and extracted via saponification. Chemical and properties of the stearic acid is that stearic acid appears as a white crystalline solid with a mild oily odor. It has a molecular weight of 284.48 gram per mole and a density of 0.9408 gram per cube. And it is insoluble in water due to its long hydrophobic and hydrocarbon chain and soluble in organic solvents. Furthermore, it has a boiling point of 361 degrees Celsius, and its saturated structure makes it stable under standard conditions. This compound is very important in various formulations due to its high melting point, stability, and role as an emulsifier, thickener, and stabilizer, making this more essential in multiple industries. Some of the regulations of stearic acid is that the stearic acid must meet the production and purity standards to avoid contamination, and manufacturers must disclose its source to align with dietary and ethical standards. These can emphasizing the transparency, rigorous testing, and also customer safety. Now moving on to the last part, which is the food applications. So from the food applications, the stearic acid contributes to cheese texture and firmness, particularly in cheddar, enhancing creaminess and mouthfeel. It helps to stabilize processed cheese, improves shelf life, and prevents clumping in cheese coatings. Additionally, it combines with other fatty acids to create emulsifiers, maintaining the consistency and quality in processed products. That's all, thank you.
Morning everyone. Today I will be discussing the role of carboxylic acid in food applications, focusing on their sources, properties, uses in food, and regulation. Carboxylic acid are organic compounds that contain the carboxyl group represented as COOH. These acids are weak and have a strong odor, naturally found in nature or made synthetically. In cheddar cheese, for example, carboxylic acid are crucial for creating the tangy flavor, improving texture, and enhancing preservation. Carboxylic acid are polar molecules because of the two electronegative oxygen atoms. Their solubility depends on the size of the molecule. Smaller acids are more soluble in water. They have higher boiling points compared to alcohols, ketones, and aldehydes. At room temperature, lower carboxylic acid like formic acid and acetic acid are liquids, while higher ones are solid. These acids can undergo reaction to form amines, alcohols, or ester depending on the condition. Carboxylic acid are indispensable in food production for various reasons. Firstly, it is for flavor enhancement. Lactic acid gives cheddar cheese its tangy taste, while butyric and propionic acid add unique aromas to each cheese. Next, for preservation, acetic acid found in vinegar reduces pH level and inhibits microbial growth. Then, for texture improvement, long-chain carboxylic acid, such as stearic acid, are used as emulsifier in baked goods, chocolate, and margarine to improve texture and stability. Lastly, for nutritional value, linoleic acid, fatty acid, is vital for metabolic process and preventing chronic disease. The use of carboxylic acid in food must follow strict guidelines to ensure safety. For instance, sorbic acid in cheese is regulated to 1000 to 2000 mg per kg as per EFSA and FDA standard. Proper labeling, including ingredients list and safety data sheets, helps consumers understand product composition and potential risks. This regulation ensures safe usage and builds consumers' trust.
Hi everyone, my name is FARHANA and I will explain about the phytosterol ester that found in cheddar cheese. Phytosterol ester are a group of plant-derived compounds that are commonly used in food and dietary supplements due to their potential health benefits, particularly in lowering cholesterol levels. Phytosterol and phytostanols are a large group of compounds that found in plants. Plant stanols are the hydrogenated counterparts of the plant sterols but are less abundant in nature than plant sterols. Consequently, normal dietary intake of plant stanol is much less than plant sterols. Phytosterol ester is commonly found in plant-based foods such as vegetable oils, nuts, and seeds. Phytosterol ester are isolated from vegetable oils such as soybean oil, sunflower oil. And for the chemical and physical properties, phytosterol ester has chemically stable fat-type materials, comparable chemical and physical properties to edible fats and oil. Phytosterol ester is also insoluble in water but soluble in nonpolar solvents such as benzene and 2-propanol. It also soluble in vegetable fats and oil. Phytosterol ester consists of a steroid skeleton with hydroxyl group attached to C17 atom of the D ring. For the food application, it contributes to the smoothness and creaminess of the product. The ability to blend well with fats and oil enhances their functionality. Phytosterol ester is also function in cholesterol lowering in human body and lowering LDL cholesterol. LDL is a low-density lipoprotein, is one of the type cholesterol found in the blood, which to transporting cholesterol to various tissues throughout the body. For the regulations of the phytosterol ester, the specific amount of phytosterol ester used in cheddar cheese depends on the formation of the product and intended health benefits. In functional food products like cheese, 0.8 to 2 grams phytosterol per serving is typically used to achieve cholesterol-lowering effects. And also, to achieve cholesterol-lowering benefit, approximately 1 gram per day of plant sterol or plant stanols need to be consumed.
Hi, my name is ELINA and I will be presenting for strict-aldehydes. Strict-aldehydes are a group of amino acid derivatives that play a critical role in creating natural aroma compounds. They are highly potent due to their low odor thresholds, meaning they can be detected by the human nose even at extremely low concentrations. Additionally, each strict-aldehyde has a distinct odor, unique to their compound itself, much like the unmistakable smell of gasoline. In this presentation, we'll focus on 3 strict-aldehydes, which is 2-methylbutanol, 3-methylbutanol, and 2-methylpropanol. Strict-aldehydes share a common feature, the aldehyde functional group, represented as RCHO, whereas R stands for the alkyl group, which differs depending on the specific aldehyde. The defining characteristic of aldehyde is the carbon-oxygen double bond, which also known as the carbonyl group. This functional group is what gives strict-aldehydes their unique properties and makes them vital in producing aroma compounds. Strict-aldehydes are derived from a few amino acids, including valine, isoleucine, and leucine. These compounds are often referred to as strict degradation products because they contain one less carbon atom than the original amino acid. For this research, we focus on the following: 2-methylbutanol, 2-MB synthesized from isoleucine, C6H13NO2, 2-methylpropanol synthesized from valine, C5H11NO2, and 3-methylbutanol synthesized from the leucine, C6H13NO2. Isoleucine, the precursor of 2-MB, is primarily found in proteins such as fish, eggs, and meat. Valine, the precursor of 2-MB, can be found in soy, while leucine can be found in dairy products and legumes. These natural sources highlights how common these compounds are in everyday foods, contributing to various aromas and flavors. Strachaldehydes, like all aldehydes, contains a carbonyl group, C double bond O, which plays a significant role in their chemical and physical properties. The polarity of the carbonyl group causes the oxygen atom to be partially negative and the carbon atom to be partially positive. This polarity affects both the interaction of the aldehydes with other molecules and the overall properties. The presence of the carbonyl group influences several key physical properties of strachaldehydes. For example, the boiling and melting points of these aldehydes are higher compared to non-polar molecules. This is because more energy is required to overcome the polar bonds between the molecules. Additionally, the solubility of these aldehydes in water is impacted by the polarity of both the aldehydes molecule and the water molecule. Since water is polar and the aldehydes have a short carbon chain 2MP, 2MB, and 3MB are soluble in water. The non-polar hydrocarbon parts of the aldehydes interacts with water molecules, allowing them to dissolve. Now, let's explore the food application of the strachaldehydes we've discussed. 2-methylpropanol is commonly used as a flavoring agent because it adds complexity and depth to both flavors and scents. At low concentration, it has a pleasant banana-like odor. On the other hand, 2-methylbutanol and 3-methylbutanol are found in cheese, where they contribute a malt-like or chocolate-like flavors. These aldehydes are particularly important in enhancing the nutty flavor in cheddar cheese. Interestingly, nutty flavors are often only present in very aged cheddar, and cheeses with high concentration of 2-methylpropanol, 2-methylbutanol, and 3-methylbutanol tend to have a stronger nutty taste. These aldehydes play a crucial role in that. For regulations and safety, strachaldehydes are widely approved as flavoring agents in foods across the globe. Let's look at the regulations regarding their use. The Joint FAO WHO Expert Committee on Food Additive JECFA has deemed them safe for use at low concentration, with no specified acceptable daily intake ADI because they are rapidly metabolized by the body. In the European Union, they are approved for use at quantum cities level under Regulation EC number 872/2012, meaning they can be used in amounts that do not exceed what is necessary for flavor enhancement. In the United States, both FEMA, FEMA, and the FDA classify them as GRAS, generally recognized as safe, allowing their use in trace amounts. These aldehydes are also included in the Codex Alimentarius guidelines and are approved for use in regions like Japan, Australia, and New Zealand. They are commonly used in baked goods, beverages, and confectionery at low concentration, typically in the parts per million ppm range. It is important to follow good manufacturing practice (GMP) to ensure safety and compliance with the regulation worldwide.
Hi, my name is Fatimah AMISYA, and today I will present about diacetyl, which is one of organic compound in cheddar cheese. First, diacetyl is a compound with rich buttery flavor and aroma. You can find it naturally in plants, fruit, and dairy products. In cheese, it's made by bacteria during fermentation, which gives that creamy and buttery taste that we all love, especially in soft varieties like cream cheese or cheddar. Diacetyl can also be produced synthetically and added to butter-flavored products like margarine. So now, let's move to the chemical and physical properties. Diacetyl or 2,3-butanoDIAN is a small organic compound with a strong buttery aroma, even at low concentration. It's a yellowish-green liquid that highly volatile with a boiling point of 88 degrees Celsius. Diacetyl also is soluble in water and alcohol, that making it versatile in food application, but its volatility means extra care is needed in industrial use. Besides that, diacetyl also plays a major role in cheese. It's adding butter flavor and aroma. It's also naturally produced by bacteria like Lactococcus lactic during fermentation. It's also common used in soft cheeses like cream cheese or ricotta, where it enhances the buttery profile. In hard cheese, the level decreases during aging, which can cause why the aged cheddar tastes different from fresh cheddar. Lastly, let's discuss about regulation. During cheese making, diacetyl is produced by bacteria acting on citrates. These factors like stirring and acidity can increase diacetyl levels. However, as the cheese ages, diacetyl decreases. It either evaporates or converts into other compounds. This also influencing the final taste. This natural balance is key to creating the unique flavors we associate with different types of cheeses. That's all from me. Thank you.